This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software. SE Radio has an opening for a volunteer host to produce 5 episodes per year. To apply, please follow the instructions on our website at se-radio.net/contact.
Hello, everyone. Welcome to this episode of Software Engineering Radio. Our guest today is Simon Wijckmans. Simon is the founder of Seaside. Seaside is focused on monitoring, securing, and optimizing third-party JavaScripts. Welcome to the show, Simon. Great to have you here. Before we get started, is there anything else you'd like to add to your bio?
Well, thank you so much for having me. Well, something I like to add is that we start with third-party scripts today, but what we want to do is basically protect the entire browser as an attack surface. So today that starts with third-party scripts, as that's where a lot of dynamic behaviors come from. But over time, we anticipate to solve client-side security as a whole.
Let's start though with just third-party scripts. And how do they actually fit into the browser security supply chain? What is the browser security supply chain to start?
When you go to a website, a lot of things happen, right? But I'm going to jump a few steps and go straight to the part where you actually get a response from the web server. An HTML page is loaded, JavaScript, CSS, etc. comes along. Depending on your framework, there may be server-side or client-side rendering. But then often in that file or in that page, there is a reference to other third-party sources, third-party domains. Those third-party domains didn't obviously get fetched. So the browser user is told, go to this other domain and get something from there. And that something is defined by that path, that full URL. But you don't necessarily know what you're actually getting from there. So you can add a hash to that script tag to define specifically the hash of the file you're expecting. But it's really up to that web server to serve a piece of content back. And so that's how these third-party scripts are being delivered to the browser of users. And that is essentially also where the problem begins of a third-party script. So on day one, you think you allow a certain thing, but it has all the capabilities for changing over time. Certain things are dynamic, and even though we refer to them assuming that they wouldn't change, in some cases they can. And so in that case, it was basically a wake-up call where if you refer to something that is dynamic, that can change, the entire context can change. And so that is also what has happened with these third-party script attacks. When people refer to a third-party script that is supposed to be a chatbot, and the week after it is actually listening to you entering passwords, then that is something it is perfectly technically capable of doing. And that is a problem.
Why do developers use third-party scripts to begin with? And sounds like they're pretty common in web dev. Can you explain some reasons around that?
So when the world moved away from using fully server-side things like PHP, and we're still actively in the process on that on some things, and Flash Player and Java in browsers, etc., became less common. Client-side JavaScript, so client-side fetched JavaScript became a much more common way of dealing with these things. And so JavaScript became supported by browsers. And people then used big JavaScript libraries to perform certain dynamic actions in browsers. And in the beginning, this was very efficient because when you went to 10 different websites and they were all using that same library, because they used a third-party domain, your browser would not have to refetch it every time as there was browser-side caching enabled for that package. So it was a very efficient way for loading a JavaScript file that would allow you to have a certain behavior in a website. Over time, this has progressed and people have luckily started moving away from using client-side fetch scripts for this use only, with tools like Node Package Manager and other registries for open source packages becoming more common. But still, these third-party scripts are necessary for certain things like analytics tools, chatbots, ads often. There's all sorts of these third-party scripts that we have to use if we want to use a certain tool. And there isn't really an alternative for many of these. So any type of chatbots tool, for instance, is often a fully dynamically fetched client-side script.
So there are cases you absolutely must use third-party, but you said things have gotten better with Node Package Manager as an example. Can you explain that a little bit more?
Yes. So for some of these third-party scripts, or used to be third-party scripts, It is perfectly possible to just get an NPM installable version of that is hostable on your own web server on your side. And a good example of this, for instance, was that polyfill.io incident. There are definitely ways that you can self-host polyfill. It's a static package that hasn't really changed in the last few years. So that is something that you can rather easily install. And so in some cases where people are not using a framework that uses Node, or it is just easier to add a client-side script, that is where people would use something like polyfill.io or CDN.js or there's a whole bunch of these JavaScript CDNs out there that serve static JavaScript. And most of those you can actually get through other means as well that are more secure.
Okay, so get them, scan them, and host them.
If they are static, then that is the best thing you can do. And I highly advocate that people do that. But unfortunately, you can't do that all the time. And so for tools that are CAPTCHAs or chatbots or ads, where there is a certain requirement for dynamicness, you may actually require, still using these third-party scripts. And even in some of these scripts that you actually can install as a static script, there are actually calls to third-party domains still happening, be it data being exfiltrated there, which can be a normal thing, but also actual fetches still happening to other third parties. And that is where basically the supply chain issue that we see on registries like Node Package Manager is also very relevant to third-party scripts.
For more on supply chain attacks for registries like Node Package Manager, I'd like to point listeners to Software Engineering Radio episode 535, Dan Loran on supply chain attacks. Before we get into more details on what developers can and should do, Simon, can you take an example of an attack and walk through it? You did mention polyfill as a recent attack. Do you want to take that example and elaborate?
Yeah, sure. So let's talk about what Polyfill did first. So Polyfill was created by the Financial Times to support, there are many different websites as large media companies often face. They have a lot of websites, some of which they handle themselves, some of which are through agencies. So within the company, there was a team tasked to create a package that would support the newer websites and the older websites across browsers and create uniformity. And so that was the project initially. So a few well-known open source contributors started working on it. And then they ended up hosting it on a third-party domain, cdn.polyfill.io. And that was then given to all of these agencies to implement on the website. And so this was a very useful piece of code. And in general, people liked it because people were moving away from Internet Explorer to Chrome at the time. So cross-browser compatibility was a big subject. So this became a very popular script. Eventually, some of these contributors moved to different things in their career. Some of them ended up at Fastly. There was sort of change of ownership conversation happening, but it never ended up happening. The change of ownership from the Financial Times never made it to Fastly. They ended up changing it to the private ownership to one of the maintainers. So this was in February this year. And then Fastly jumped on that subject and put a blog post out to alert people of this change and offer a mirrored version of it essentially on their own CDN. And the same happened with Cloudflare. Cloudflare did the exact same thing. But unfortunately, as a result, nobody did it. Nobody actually took it seriously and removed that script and changed it to the other hosted version.
This was a blog post. How do you even know how many people read it? And what are they supposed to take away from it?
There wasn't really a good, serious way of putting this to people's attention at the time because nothing bad had happened. There was a suspicious chain of ownership to a Chinese company. Nothing had happened at that point. Okay, then fast forward a few months to the 25th of June. And if you had that script on your website at that point in time, this Chinese company made an adjustment to the code where if a certain user agent were to request that script, they would also get another script with it. And that was hosted on Google Analytics.com. So Google Analytics with an L as an I. And that would end up redirecting you to adult content websites and online casinos, which looked like a rather juvenile attack. Of course, when that happened, we were one of the first ones to notice.
How did you notice it?
That's a good question. So, of course, there's a lot of websites that all of a sudden this happened. We've got a lot of features that we monitor. There's, of course, outcry on social media when these things happened. We were very much in an early beta stage at the time, but we still got the intel to come in essentially to take it from there. And so essentially the first time we noticed it, it took about 60 minutes for us to put a blog post out since, because we noticed it was rather distributed at the time. We personally bumped into it when we went to these websites. But the interesting thing is that they made the script only inject that malicious code once per IP address. So they made it harder to basically understand what was happening. So that was interesting. And then, of course, when we noticed, we made a blog post, we reached out to our PR consultants, we got it in the news, and then everybody kind of jumped on it. And for some time, there was wide-scale chaos, but nobody was really taking action. Thread feeds did not mention it anywhere. So for 30 hours, everybody knew it was bad, but thread feeds were still saying it was okay. And then eventually Namecheap, the registrar of the domain name, jumped in and purchased the domain name kind of back. I don't think there was actually a change of money, but what they did is they removed any of the DNS like objects or DNS queries. And as a result, that domain name was no longer responding to anything. At the time, that was on more than 490,000 websites. To this day, it's still on more than 380,000 websites. If Namecheap hadn't done that, this attack would still be on today. That is what we know. If you'd allow me, I'd like to explain what likely happened, but the problem is that the evidence of it is not 100% there. So, word on the street is that a life-changing amount of money was offered to the then personal maintainer of the polyfill.io domain name. And that person was presented a solid business case by a Chinese company that wanted to use it to host CDNs and all that stuff. Okay, so the change of ownership happens, person gets the money, nothing bad happens initially. Now, this is a script that's on 500,000 websites. And some of those are large news websites, online HR platforms, you name it, there's some really, really massive logos in there. The expectation is that between February and June, it would be kind of silly that they would have such a high value resource available and do nothing with it. So what we expect within the security community is that based on the referrer header that was used to fetch the script, because at that time they moved away from a CDN hosted script to an actual web server responding, depending on the referrer header and perhaps some other headers, they would actually send a malicious payload along and pull off a much more stealthy attack to potentially steal information like identification information, HR information, could it even been, or adjust content on news websites or whatever. It could have been anything, right? And then as a result, they would be successful in that attack. They would have the data that they need. And then to blow it all up and basically kill the story and get people to think about other things and remove their mind from polyfill.io as a potential thing, basically close the subject, they would make this incredibly noisy attack happen in June. That's what we think happened. And the reason why we think that is because, first of all, by redirecting people to adult content sites and online casinos, you're not going to make life-changing money. So there is very little financial incentive to do that. Because the script was able to only inject bad things for certain user agents and only once per IP address, they were clearly aware of the advancedness of the attack that they could pull off. It just wouldn't make any sense for people to spend that amount of money to then do that type of a juvenile attack. That is what we think. The problem is we'll never know because nobody's keeping an eye on their client-side behaviors. There's no real good monitoring solutions out there, aside from what we're trying to build to actually monitor the behavior in the browser of a user. So the fact is we'll never know. And that's the real issue with client-side security. This attack vector has been around for a long time, but we've not really had good solutions to it for a very long time. So we don't know how often it happens until it's a very visible and very wide-scale attack. So that's that.
I do have some questions on what you mentioned about word in the street, but I guess you cannot really answer with any degree of certainty. But so the thing that I will take away from this is that just that these attacks are so easy to pull off, right?
Basically, if you get your hands on something that delivers a script, is in the flow of the delivery of a script, you've got it. And that could be anything from the IP range, the domain name, the storage bucket, or even just have access to the open source repo of it. And if it has CI and it deploys that script in actual production eventually, then there you go. You've got a malicious third-party script in your hands. So yes, it is very easy to pull off. There's actually a really good blog post about this that went viral in 2018. It's called "I'm Harvesting Credit Card Numbers on Your Site, and Here's How." It's a really good blog post. And basically every word that is written there is still possible today. Luckily, it's fictional, so it was only a joke, but nothing that's written there is impossible. And it really shows how easy it is to execute an attack like this.
I'll put it in the show notes. Why has there not been more focus on third-party scripts? Is that increasing now? And why now?
So there's definitely been a flood of these types of incidents since 2010. And I would say it kind of peaked before COVID, around 2018, 2019. There was a very widely covered attack back then on British Airways, where, again, funny enough, the same kind of number, 500,000 people's credit cards were stolen roughly. It was about 460,000 roughly. But yeah, people's credit cards were stolen, and that was also a third-party script. Although they also managed to get access to the actual web infrastructure of that web server, they injected a script that would monitor for these credit cards. And they would exfiltrate that information to a domain name, and that domain name was baways.com. So a domain name that looked as if it could have been from British Airways. Well, today we actually own that domain name. So if people want to read up on what happened with that incident, they can go to baways.com and they can see actually what happened then. But it basically hasn't gone away. And I would say that kind of the media got bored with this subject, and the security industry wasn't really building anything for it. So it was one of those annoying situations where it happens and there isn't really an elegant solution to it. And unfortunately, the problem is likely going to become way larger. And that's for a few things. So first things first, we are doing a better job at protecting our web infrastructure. We're putting proxies in front of it because of Cloudflare's incredibly generous offer of giving free proxies to everybody, or a very cheap pro and business tier. A lot of web infrastructure is now protected. So pulling off a very simple SQL injection attack isn't as simple as it used to be. More and more of these great tools like Socket.io Socket.dev, are around and help you protect your open source dependencies and keep an eye on those. So they make sure that whatever you get from NPM isn't causing any trouble. But then, of course, the question is what remains left? What is an attack surface that is powerful enough to pull off a serious attack, but is currently not really being monitored? Well, the answer there is the client side. An NPM package installs something that is actually allowing dynamic fetching in the browser of a user. That could be a big problem. If people add third-party scripts to their website, that could be a big problem. And the thing is that most websites nowadays don't actually monitor any type of client-side behavior at all. They don't have the tools for that in place. The tools for that are also not incredibly accessible. They are rather expensive. They're usually part of a larger enterprise commitment with a security company. And so therefore, this has just been a problem that's been luring in the background, and there was a lack of solutions for it. And so we took action. We recognized this issue, and we decided to do the hard thing, but also the right thing of building a service that's able to deal with these types of attacks.
Thanks for that, Simon. Though I just want to point out, at least the way I understood it, the British Airways attacks wasn't really a third-party script, right?
Well, the British Airways attack was an interesting one. So through getting their hands on credentials of a contractor, they managed to work their way into the internal network of British Airways, get their way onto one of the web servers, and then they added a third-party script that exfiltrated this data. Well, or they adapted a third-party script actually to add this code, or a first-party script actually to add this code that would exfiltrate credit card information to a domain, and that was baways.com. But the reality is that this behavior got executed client-side. That's where the bad thing happened. Nowadays, with tools to read through code and analyze certain behaviors, you likely could have spotted that specific one, but then there's also many other ones like the EasyJet attack. There was another one on another airliner at the end of 2023 called Air Europa. All types of retailers, all types of booking sites, all types of, well, basically any company that accepts credit card information online or has a substantial amount of traffic going to their website. And by the way, this is not as hard to pull off as people may think. If you have ads on your website, you're essentially giving a third party the ability to sell space on your website. And guess what an ad is? An ad is often a piece of JavaScript. And so adware is another way to refer to this threat. And the thing is that as people use large ad providers, they have done a good job at defining which APIs those ads can use and which they can't. But as you start looking for higher margin ones that are maybe less reputable providers, then that security is not always there. So the issue with third-party scripts is still a very major one and has impacted many websites over the years, essentially as soon as JavaScript was added to browsers.
So you mentioned ads and analytics as the key source for this requiring third-party scripts on your website.
I would say ads is the most easy one to get an attack into a website or in a wide amount of websites, but then other tools like analytics, chatbots, etc. These are often industries where there are lots of small vendors, and those small vendors do not necessarily have funds to protect themselves very well. Some of these companies can randomly cease to exist or get acquired, and a few years later, it is not necessarily clear anymore who's keeping an eye on that script. Another example I like to refer to is companies that provide a third-party script that are not inherently very technical in its core existence. So as an example, for instance, there are influencer marketing firms out there whose core product is their catalog of influencers that they represent. But then they ask you to add a little script to your website to track the conversion, the sales that happen as a result of people clicking through from TikTok to the website. Well, those people often, they literally get a contractor on board to help them build that script. They build it, they make it, they ship it, they walk away. They may be on a retainer, they may not be on a retainer, and that script now lives in a bunch of websites. And those are the types of scripts that we see getting exploited the most out of like all of these other scripts. I would say analytics companies, they have been grilled on this issue. And because of these attacks happening in the past, of course, they are aware that they have to take action to make sure that they're safe. That message hasn't really made it to every different vertical of third-party script provider.
So what role does the open source community play here? What do they do and what can they do better?
I think the open source community can help here by making sure that whatever features and tools they provide are available in a format that people can self-host or people can install through a registry like NPM, so that at least there is an ability of transparency where you can see these things. So avoid building third-party hosted scripts, avoid using them to the furthest extent that you can, and mostly be very transparent about the security that you have like implemented if it must be a third-party script, how you seek to protect your actual infrastructure where that script is being hosted, how you make sure that your CI around it is safe, make sure that you own that domain for a long enough amount of time so that it doesn't all of a sudden become a surprising situation when it doesn't get renewed. Those are all things you can do. And then another thing that the open source community can do that I think is kind of underappreciated, but if you're building something that likely will end up in a third-party script at some point, immediately buy the domain and own it. Because if you're not going to do it, someone else is going to take that code you wrote, mirror it, and buy a domain name for it. And people are going to think that you actually own that domain name, when that isn't necessarily the case. And this is essentially what has happened with Polyfill. The open source contributor that built that script was not the one that owned that script. And that, of course, creates a headache for everybody, right? Because you don't really know the full extent of that person's technical ability because they didn't write that thing. They are an entirely different third party to work with altogether. So that's another thing I would say the open source community can do. And then, as always, if you bump into a bad script, report it, make noise. That's how threat feeds get their data. I personally don't think threat feeds are the answer in 2024 because there's just too many things happening for threat feed providers to keep an eye on. And unfortunately, threat feed providers themselves get acquired. Their engineers leave. Like any business, there's rotation happening over the years. And their quality is not guaranteed. And the security world tends to rely too heavily on threat feed providers to tell them when something is bad and when something needs to be stopped. And that is another thing that I would say we need to start pushing back against. We cannot get away with buying security products that are basically a wrapper around a third-party threat feed that you can get either for free or that is just so commonly used that by the time it makes it onto the threat feed, the attacker knows and they've moved on to a different attack. To loop it back to that Polyfill incident, it took about 30 hours for that script to be added to a threat feed. And that is really not acceptable. 30 hours of a malicious script that could have done anything from mining crypto in browsers, stealing people's sensitive information. 30 hours of the whole world knowing that it's bad, of it literally being on news websites before a threat feed added it, is not good enough.
Is there any relation to browser plugins and third-party scripts in terms of mechanisms or security policies, etc.?
Yes, for sure. So under Manifest 2 of the Google Chrome extension store, so Manifest 2 is a file that you add to your Chrome extension when you ship it onto the store. You are perfectly allowed to inject third-party scripts in the sites that people enter. So when you as a user install an extension on your browser, the extension is able to inject a script. And fortunately, there are certain industries that are really heavily targeted by malware scripts. And those are online betting websites, cryptocurrency exchanges, cryptocurrency sites in general. There are a lot of really nasty plugins out there that try to steal all sorts of information out of those. So this is another thing where I feel we need to be a little more cautious. It's not because something made it onto the Chrome Web Store that it is safe. The team at the Google Chrome Web Store that manages this, they likely have some type of review mechanisms in place. And in fact, there's 2 of them that they make public in their Chrome Web Store. But the reality is that as soon as there's a third-party script in there, they don't really know with any level of certainty what they're actually getting from these third parties. Because the only thing that third party line of code in that script is a reference to another web server. And while you can check that web server today, you're not certain how it's going to behave tomorrow. And in fact, what I'm seeing can be different from what you're seeing, right? And that's another element here is the most aggressive attacks that have happened of this type. They last for many weeks, if not months. And they lasted that long because they were able to fly below the radar by only injecting in a certain percentage of users' browsers in specific regions under specific circumstances. And if you rotate that every couple of hours, and you say, for instance, West Coast US gets a bad script 1% of the time if they have a certain user agent, and you go to another region, you fly below the radar for so long that even if people are complaining about it on Twitter, the threat feed vendors will probably not add it to their threat feed because they cannot reproduce the attack. That is a major issue. Dynamicness of scripts, in general, referring to a third-party domain and trusting whatever you're getting from there, is just not great. And unfortunately, there are some tools that will only work if you do it that way. And that's where we have to come in and provide solutions so that at least when you use these tools, you are given some level of security.
Thank you for that, Simon. I was hoping, and tell me if we can do that, is just as an example, take a site that you might have investigated in the past just to see how many and types of third-party JavaScripts it has. You made a point earlier on the show that a lot of websites have the polyfill even though they may not have needed it anymore. So there are legitimate cases where people have third-party scripts, but also sounds like cases where, people just haven't taken the care to remove stuff they don't need. Is it possible? Do you have an example site that we could check to see what kinds of third-party scripts it has?
Yes. So on our own website, you can enter the domain of a website and it will go there. We will crawl it. And unless they have bot detection, we will tell you what third-party scripts are on that page, how many there are. We will crawl a few pages. We'll tell you whether there are scripts on different pages, etc. I don't want to name call anyone specific here, but there's a very large sports clothing e-commerce brand out there that I think many of us have items from. We have over 120 of these on their website. And it's ranging from a range of analytics tools, some of which overlap in functionality, to, as I said, a chatbot or CAPTCHAs or tags for certain social media tools that are also scripts. They are using some special AI tracking capability that helps them customize the store for the types of things that you have looked at in the past and your other heuristics that they have on you. 120 of these fully dynamic things is a totally impossible number to manage unless you have a tool for it. I like to refer to it's basically babysitting 120 fully dynamic babies that have not had a nap and they're still kind of highly energetic and annoyed. You just can't handle that many. You can maybe handle one or two of those by visiting them regularly and making sure that there's no suspicious behaviors like new SSL certificates being issued for that domain or changes of ownership of the domain or code changes that look out of line. But as soon as you have more than maybe 10, it's entirely impossible. And that is the reality. If you go around the web, open the developer console, have a read through their head tag, look at the third-party scripts that are loaded, also in the main of that page, you will see that there's a lot of them. And in fact, modern frameworks like Next.js and most single-page web app frameworks, they make this problem worse because as you navigate through pages, or so it looks you're navigating through pages, the pages are not actually fully being re-rendered. So the previously present third-party scripts are still present on the next pages you are. So as a developer, if you make people route to the payment page, do a hard refresh. Make sure that there actually does a full window refresh and it's not just changed URL in the nav bar. That is another common thing that we see, that there are payment portals present on websites and all of the other scripts from the other pages are still there, even though if you manually refreshed on the payment portal, those scripts wouldn't be there. So at least somebody knew about the problem. But because of how single-page web apps work, they are still there.
So we know there are risks, and you mentioned data exfiltration, where data is sent over, and maybe this is the example of the payment, where I enter my credit card information and the third-party script sends that information somewhere else, right?
Yes, that is kind of a very serious type of attack here. And to be clear, this has happened so often that the PCI DSS spec, so the payment card industry specification, that we all have to adhere to for accepting payments online, their fourth generation, which is kicking in fully in effect in March next year, they require you to keep a list of these third-party scripts, why they are there, and have tamper-proofing in place to keep an eye on them. So as they change, that you're alerted. So that is a very specific type of third-party script attack that happens so often to the point that they particularly had to call it out in essentially compliance. And that has actually had an interesting side effect. When you get cyber insurance, they'll ask you about your PCI DSS status. So if you go through that form real quick and you say, yeah, I'm fine, and then some incident happens and it turns out, well, actually, you haven't really lived up to the spec of PCI DSS, it could be that the cyber insurer just says, nope, we can't cover you here. You've not actually taken the responsibilities that you had to take. So then there you go. It's unfortunately a very common one, that one.
I will put a link. I've noticed a blog post on your website on this, so I'll put a link to that in the show notes.
SE Radio has an opening for a volunteer host to produce 5 episodes per year. To apply, please follow the instructions on our website at se-radio.net/contact.
What else beside data exfiltration?
Also, you have data exfiltration of credit cards, users' credentials. You can mine crypto in people's browsers. Browsers have become more powerful and more capable, and we've added so many more new cool features to it that we're using for all types of legitimate reasons. But those can all be used for illegitimate reasons as well. So as people are building progressive web apps, those often store local data, sensitive data locally in a browser session. Well, an example there is that there are third-party scripts out there that look for that sensitive information, and as soon as you reconnect back to the internet, would upload that information. So that type of data exfiltration, I would say, is rather new. The mining crypto one kind of peaked and has since come down a bit because there are certain levers built into Chrome now that would alert to an extent, but you can still stay below the threshold, so it's still kind of an issue. But then there's also other ones like malicious redirects, malicious rewrites on pages. I mean, anything that can happen within a browser really can be used to an extent for malicious use. Logging you out from all of your other sessions, unfortunately, is also a thing you can still pull off. So logging people out to just annoy them, you can do that.
So as you mentioned, it's only a problem on, keeping track of how things are changing. But to begin with, how can developers decide if a script is good to use? Is that the reputation and reliability of the provider? What should they look for? Any red flags?
Yes, so that's usually my first recommendation is make sure that if you implement a third-party script on your website, that this is a company that gets that is a major security risk and that they have to protect that properly. So don't trust some random person on Twitter that made some analytics tool and is very early in career and doesn't necessarily express that they get a security risk. That's the sort of thing that I wouldn't really trust. But then the next stage that I tend to recommend to people is try and create 2 buckets. A bucket of tools built by actual technology companies, people that get engineering, get how to write safe code and get the importance of it. And then a bucket of companies that, quote unquote, we also have a script, right? Or can you add this script real quick? The issue there is that those types of companies are usually, that's not their core business, and they tend to do a worse job at protecting those. And so those are the ones that I would always seek to avoid. Well, then as a next step in that framework, I would say, if you can self-host, or there are 2 options, and one is one you can host, and one is like a fully dynamic version, then try and go towards the one that you can self-host, because that's the best way to deal with the security risk. Unfortunately, for some tools, that's just going to be impossible, or the static code that they give you to self-host actually still refers to third-party things and third-party dependencies. So be mindful of that. And then eventually, and this is a sad reality, you are probably going to have some dynamic tools on your website. So taking into account the reputation of those, you should still likely use a tool like ours. And that's why we have that free tier. That's why we have a cheap business tier, so that you can actually go ahead and just use it. You don't have to worry about it. And those third-party scripts that are dynamic, they're now flowing through us. So at least we're keeping an eye on how they behave for all of your users. So if a user in Hawaii at 4 p.m. in the afternoon gets a different script from what you've seen on all of your other users, well, then at least we'd be able to alert you for that. And then, of course, the other things that you can do that I always recommend people to consider, but in general are bad developer experience. Use things like content security policies to define the domains that you want to allow to be fetched by the browser of your user. The painful thing is that doesn't actually solve a lot. It only allows you to define the sources. It doesn't allow you to define the payloads necessarily. So that doesn't solve the entire problem. And then in case scripts are actually static, then also adding that hash of that script to the script tag to define that is the hash that should be allowed and nothing else. You can still work your way around that, and bad actors have historically found ways to do that, but that at least gives you some level of certainty. And security is all about layering. So you add a layer, you make the risk smaller and smaller and smaller until it is a negligible risk, and you can demonstrate that you have done everything to the furthest extent possible that you can with the technology available. And then, of course, there are just tools that make this easier for you. That's what we've built.
I do want to talk a little bit more on the browser security controls and content security policies. But before we do that, is there anything unique here with respect to mobile?
It's interesting because mobile browsers are slightly different from desktop browsers, but there are many different browser engines out there, right? Chromium is definitely one that we see most of the time, but got WebKit being used, Safari. There's a whole bunch of exotic ones and people building new browsers, which are generally things that I support. The reality is that we often use browsers without actually realizing that. A progressive web app, a web view are essentially browsers, and they have the full attack surface of a browser. So when it comes to the native security aspects that you can use, well, a progressive web app, because it is essentially a browser, also supports things like content security policies. Some things like WebView can, but not always to the fullest extent, or the behavior is ever so slightly off. There isn't really much more that you can do within a PWA or WebView that you can't do in a browser already, because they are inherently just web apps. So, but my advice towards people, and I always say, like, I don't really want to give advice because this is a subject where, unfortunately, there's a lot of nuances. But generally, my advice towards people is, if you're using anything that's a browser or PWA that really is just a browser, make sure that you have as much control over your code as possible and use the right tools, and understand that security is about layering. So use something like Socket to protect that open source dependency that you load through NPM. That is the better thing to do. And then for the client-side fetch things, there wasn't really a good solution. Well, that's what we went out and built.
So back to, managing third-party script dependencies. One of the first things you said is self-host if you can, but then that gets to be a problem because the JavaScript could be having other calls to other third parties. Can I ask a naive question? Can't you just pull them and self-host the dependencies yourself?
You can, but in some cases you can't. So I'll give you an example, right? So let's say you're using Intercom as a chatbot on your website. Well, of course, someone types something into that chatbot, that data gets sent somewhere. Then you correspond with that person through a fancy dashboard, and then they get a message back. Well, these are dynamic behaviors, right? And that must be dynamic. So some of these scripts you simply cannot self-host in their entirety. And that is for analytics and chatbots and CAPTCHAs and ads and third-party video loaders and all of these types of things. They are inherently dynamic. That's their functionality. There isn't really a good workaround for that. Luckily, some of these tools, they have like server-side rendered versions available, or some of them have sort of middleware version available, where if you're using Next.js, you can do some of these things in like Cloudflare Workers, basically sitting in the middle. But the reality is that they can pull off a lot of these same malicious acts over there. So the attack surface is just slightly moved to another area that you're not protecting. And that's a major issue. So you simply can't always. It would be lovely if we could, but then we are back to a world where we don't really have much dynamicness. Of course, if you built your own chatbot into your website and you actually like own the whole package, or you found an open source thing that you could self-host yourself, yeah, that would be amazing. But when I built my own business, that was the first thing I realized doesn't scale, because self-hosting these types of things versus just paying somebody to maintain it for you, you can't open source everything and then have to maintain it and deal with it yourself. Sometimes you gotta actually pay somebody to do a better job, right?
So there is no brute force approach. You do need to figure out how to handle third-party scripts. Back to browser security controls. You mentioned content security policies. Can you drill a little bit more into that? And what else is there?
So content security policies are basically a header you add to your web page when you are the web developer of a page. And in there, you've got, I think, a little over 30 different directives you can add. And that's anything from like connect source to script source to adding things like specifying, for instance, that certain fonts are allowed to be loaded, but not from certain sources, etc. You can go quite far into detail about it. There's a lot of things you can write there. And it's all in the Mozilla documentation. So you can drill your way into that and see it. And also you can add logging endpoints. So for instance, if something breaks a certain rule, then you could receive a log for that. Content security policies are currently going to their sort of third major wave in existence. So CSP3 is around the corner. And so in CSP2, there were certain limitations that made it hard to love. So for instance, you could actually report back the first 50 digits of a third-party script so that at least you could verify some of the payload. But then, of course, guess what bad actors did? They just made sure that whatever bad thing they changed didn't show in the first 50 characters of a script. With CSP3, there is a deeper specification towards hashes and those types of things. But in CSP3, there are still certain limitations that I personally find it making a suboptimal thing to use. So ultimately, it still comes down to the same problem. CSP policies define third-party paths, third-party scripts, as in to serve the actual URLs that you're calling, but they don't do much with the payload aside from adding a hash, which, by the way, you could have added to the script tag itself anyway. So that's one of those controls. There are other controls, but I would say CSP is sort of the major one that is used for client-side security today. And over time, hopefully more of these get added. As I mentioned, there are just more functionality being added to browsers every day. And as a result of that, we also should be looking for ways to secure these things. As I mentioned, adding more things that allow you to store sensitive information in the browser of users. Examples for that are, for instance, IndexedDB, but also WASM, or that allows you to do basically virtual machines in browsers or chucking containers in browsers to an extent. There's just a lot you can do there. And those things need security as well.
So on the CSP, you mentioned that you can limit the sources that you're pulling the script from. What happens though if your script that you're pulling is now referring to other sources? How do you even know what you should be limiting?
So that's where that logging capability is so useful. So there's a report-only directive within CSP that basically you can just add to any type of CSP header you added, or at least most of them support the report-only header. And what it does, it just literally sends little packages to an endpoint. And you can then read into those packages and you can get a list of those third-party scripts that were being loaded. And as you mentioned, indeed, if a script calls another script and that script calls another script, you're working your way down that list. All of those will be listed in CSP. Then you, of course, now have a list that is current today. But that is, again, sort of the reason why people don't tend to like CSP policies very much. If these scripts change and they add another URL to that script or another dependency, and you haven't updated your CSP policies, it's going to result in it breaking because that dependency is not going to be loaded. And that, I think, is a good indicator of why content security policies haven't really reached wide-scale adoption. Because as soon as you're using it and you're actually defining things to the level of strictness that it should be, then as soon as you do that, then it's just a matter of time before certain third-party tools are going to break. And the reality is that the people that implement these third-party scripts, they're often not actually the ones that chose them or use them. It's often another department within a company. It's somebody in marketing that asked about an analytics script, or somebody in support that said we use this tool now, or somebody in legal saying we now need to add a cookie ban. Or there's so many of these scripts, the engineers are not the ones that use them or chose them, and they are somehow the people that have to go to their laptop if they start doing weird stuff for their CSP policy breaks. And that just makes for bad user experiences. So there have been kind of suboptimal attempts at closing this risk down, but the reality is that the risk itself is also something that a lot of good tools kind of thrive on. That dynamicness allows you to quickly ship improvements to your tool, add new features to your tools. And that dynamicness then allows you to do great things. But as I mentioned, that is also kind of the dark problem about this. And so CSP doesn't really address that issue.
Mm-hmm. So CSP is more like better broken than insecure, in a sense.
I think the risk is mostly that you're just going to eventually have an issue. Eventually, you're going to have a script breaking. And also your local development experience may be worse, right? Because you're using an actual production. You may be referring to certain third-party scripts locally when you're doing your local testing. You might be using some extension that also loads a script. Your behaviors are going to be different. And by the way, if you start looking at content security policies on big websites, you will see funny things. People referring to googletagmanager.com with a wildcard, which is essentially bypassing the whole point of CSP because anybody can host something on Google Tag Manager. So it doesn't quite solve anything, really. I mean, the reason why people add those wildcards is because there's also limits to the length of the header. So if you have 50 scripts on your website, you probably can't reference all of them in their full URL format. So you start adding wildcards to it. And as you add a wildcard, you open up to bigger problems. So content security policies are a bit of a headache. And luckily, there are tools that make it easier to manage them, but they are not going to solve really most of these attacks. And they are just a bit of a cumbersome thing to use. So there must be something better, is what we thought. And then we went ahead and tried to build it.
What about sandboxing and the third-party scripts? Would that help with some of the an example you had earlier where unless you refresh the page for where you enter payment method, you still have third-party scripts that have no business being on that page?
The thing is that the requests make for different responses, and as a result, the answer to this is it depends. So if I make a request from my laptop using a certain user agent on a certain website, a certain time of the day, using my IP address, that's going to give a certain result. And that result could be the same if I'm going to that from a sandbox environment hosted on AWS, but that could also be different, right? And so what we've seen is that scripts behave differently as soon as you're a security company and you're using an easily differentiatable way of doing a request. So I'll give you an example. If you're using a tool that crawls a bunch of websites from an AWS IP address or from an actual residential IP address, you'll see different behaviors. It's the same with these third-party scripts. So if a bad actor were to see a request being made from AWS or GCP or any large cloud provider that security vendors use, then it is incredibly unlikely that they would give you a bad version of the script. Usually these attackers, they have a clean script and they have a sort of quote-unquote dirty script, the one that has the bad code in it. And the bad code is reserved for people that they know are going to be actual humans using heuristics that are actual, normal humans. And as soon as they see an automated request or a request coming from a cloud provider, they would either just 404, not serve anything, or they would simply give the clean version of the script. So that is an approach that I've seen, honestly, give more false security than real security. There are examples of attacks that are incredibly dumb that you can just detect that way, but the reality is that a bad actor that is really targeted, they would be able to deal with that very easily. So a sandbox for third-party scripts, I don't think is necessarily the right way.
Sorry, maybe I didn't quite pose my question properly or didn't fully understand your response. What I was trying to understand was, is there a way on my webpage if I'm the website owner, could I limit the access that third-party scripts have by putting them in an iframe or something?
Yes, definitely. So you can use iframes. The behavior of that is rather well defined and rather consistent across the browsers. So you can define more specifically what type of things that it's able to do and try and limit access. That is definitely something you can try to do. However, some of these scripts don't like that, right? So I'll give you an example. For instance, the Stripe third-party script that you use on your website when you add Stripe, it has to be deployed globally on your website. If you don't, then they will shout at you. If you try to proxy that script, by the way, they will also shout at you. If you try to self-host it, they will shout at you. So there are things you can try and do if you're very creative. I personally have not seen that being implemented on almost any web page. Even very well-known good security people, they get caught by these third-party scripts. They don't do these more exotic security tricks. So the answer to it is probably you could, but it at that point becomes a harder thing to manage over time. I'll give you another example. There was a script that we were able to proxy for some time, and all of a sudden it changed and it started causing some issues, right? We have built a whole pipeline to then stop proxying and do something different with it to still keep an eye on it. But the reality is that happens because these are dynamic. And so it could work today, could stop working tomorrow, and you now have another thing on your website you have to keep an eye on.
What do modern web frameworks help with any of this? Maybe React, Angular, is there any help they provide developers in securing third-party scripts?
Not really on the framework level, I would say. So progressive web apps, I think, are a good example of how this problem became more hidden and is still very relevant. And then single-page web app frameworks, they actually do cause this issue to be more severe. Because when you navigate from page to page, because it is a single-page web, it doesn't actually fully re-render the page, and those third-party scripts remain on that page. So You can navigate on an e-commerce website from the homepage and select an item and add it to the cart and make it to the payment portal, and your browser never actually did a full refresh, and therefore all of these third-party scripts are still there. It would be awesome if in frameworks they were more conscious of sensitive data fields, and as soon as there are certain scripts present or certain actions present within a page, that it would trigger a hard refresh for you. But today we rely on the engineers to manually make that happen. So when people navigate to the /payment page, that it does actually do a full re-render of the page instead of that like the client side re-render of a page. It should be a full refresh.
So, it sounds like it's only hard to do, but there are a series of best practices that developers should follow regardless, right? At least take care of the things you know about. In the category of monitoring and keeping up with changes, what are some of these best practices?
For monitoring the scripts, the thing that I did in the past was the most commonly used scripts. I would have a little Lambda function for them to call them, and I would create a hash. And as soon as the hash would change, I would have a quick look at it. Usually these scripts are obfuscated or minified, so they're harder to read. But you can deminify or deobfuscate them, and that's a legitimate reason to deobfuscate for security analysis. Every now and then you can have a read through them.
In the previous elaboration, you just talked about adding a Lambda function for hash to the JavaScript so that you know when it changes. I've also heard of something similar that browsers support, but not necessarily in the same way, sub-resource integrity. Can you explain what that is?
Sure. So I referred to it a few times in other sections of this podcast, but if you add a script to your website or a link or any type of third-party resource, it's actually a directive that is widely supported for various tags. You can add a hash of that third-party object resource to the fetch object that you use. And so that allows you to basically say, if anything doesn't match this hash, don't render it, don't run it, don't execute it. And that's incredibly helpful for dealing with static resources. So if something is hosted on a CDN and it shouldn't change, then you definitely should add that hash to that script source. However, we notice that it isn't as widely adopted by people, and there's a few reasons why. So first things first is sometimes hashes are used that create a false sense of security and are actually bypassable. For instance, an MD5 hash. You can generate bad code into good code and then obfuscate in a certain way so it matches the same hash. That is possible. But then mostly, and this is the most common problem we see, is if you actually use a script that does change over time and you added a hash to that script, well, then of course what's going to happen is as soon as that changes, it would get blocked, it wouldn't render. And that incident in general happens a lot for people, and as a result, they don't use the sub-resource integrity as much, which is sad because it is a useful thing. So in general, we do tend to recommend people when they use an actual static thing that hasn't changed in a certain amount of time, just to cache it. And then also you can self-host it and add that sub-resource integrity header to the object.
You mentioned CDNs. Do CDNs have to do something special to support this? My first thought was, if the script does change, shouldn't it become a different resource?
Yeah, and then the hash would not match at that point. So, a CDN really shouldn't allow this thing to be dynamic. So I'll give you an example. For instance, if you use CDN.js, which is hosted on the Cloudflare network, you actually get the hashes in the web page, right? So you should be able to use that. Well, of course, then the CDN provider should make sure that those objects never change. There was actually an incident a few years ago where the CDN.js release pipeline had a breach in it. And luckily, nobody found out except for a white hat hacker that then flagged it through a bug bounty program. But that could have added some real issues, right? Because that provider, if people didn't implement that hash on the script source, that could have added to a massive supply chain attack. So in general, CDN providers should just make sure that whatever they host is well protected, is static, and probably have some controls in place themselves to make sure that that remains the way. I think it becomes a more serious issue if these scripts start calling new third-party dependencies. I tend to have a manual look at those anyway. So those are things you can do. I think the risk of a script doing something bad without a new third-party domain added to the script, it's smaller. It isn't always easy to detect because sometimes they're base64 encoded. But as soon as I see that there's a third-party script added to a script or a new third-party endpoint to send data to or new post requests being sent to new domains, that's when I tend to have a look at scripts ourselves manually. That's what I did in the past. Our tool now does that for us. We use AI to parse through these types of changes through the entire code. And then as a result, we're basically able to automate some of these detections. Some of these, I would say the majority of these detections we actually have automated now. So Seaside as a product is kind of the manual review process that I used to do as a PM building similar products.
Let's talk about that a little bit more. You mentioned using AI. Can you elaborate? Like, how do you do that? How do you train? How does that actually work?
So it's pretty cool how there's a lot of cybersecurity companies out there now that are basically taking the securities analyst tasks and automate them and use AI to deal with the obscurity of that job. And we have basically built that in for our use case. So because we have full access to the actual payload of a script, we need to review that. We, of course, have a range of static detections on top of that. We look at things in changes over time. But then we also use readily available LLMs that we have either made small changes to, or we are using the stock version to analyze these scripts again using specific prompts. And the results of that are surprisingly good. Humans, of course, read JavaScript, but as soon as it becomes a very large file, our success rate starts to drop. And that is also something that we got to recognize that we are not that great at that sometimes. We get more consistent results today using some of these modern LLMs, and they improve pretty much every week. Every time there's a new one, we try it out. Those are able to explain to us what these scripts do, how they have changed compared to a previous version of it. I don't want to go too deep into our detection capabilities, but the LLMs are pretty decent at going through third-party JavaScripts, especially if we give them the unobfuscated versions of it, the deminified versions of it, and then figuring out whether something looks a little weird, whether it requires further review, and then we go from there.
So could someone sign up to Seaside to just try this review capability?
Yeah, so currently the free tier is not going into a lot of detail on how we detected that something is potentially malicious. We tend to just take action on your behalf. The great thing is that these third-party scripts, when they go bad, we obviously also want to make sure that more people are protected against them. So for large attacks like the polyfill one, we do blog posts and we want to make clear how these things have happened, and we will probably talk about them in places like this. So that's currently the best thing we can do for our free tier users. As of course, when we open up too much, the risks are that people will reverse engineer detection capabilities and try to bypass them that way. So the free tier is, I would say, a good way of not having to worry too much about it, but it's not giving you a lot of detail, which will probably mean that at some point you want more detail. And that's where the business and enterprise versions give you a lot more context and also more ability to define lists, block things, allow certain behaviors, allow certain data extractions, define that list of scripts you want to allow on the payment portal to comply with PCI DSS. Those types of things are then part of the other tiers. I find it incredibly important that today we move security from an enterprise-only business to a more accessible business, because web security shouldn't be enterprise-only. And that's why we have that free tier. That's why we have that rather affordable business tier. It's currently priced at about $100 a month. That is there so that people with a neat podcast website or a good personal blog or a side project e-commerce store where they sell socks with a picture of your dog on them, that they can at least be sure that they have their security covered. And that is something that we try to do, well, regardless. I personally think that that's sort of the most rewarding thing about what we're doing, the fact that we're taking web security and we're making it more accessible to people. Because when we're really realistic about it, if you have a couple of $100 to spend on web security, there aren't that many vendors that you can go to. We want to make that easier.
You've been talking about a proxy. Why a proxy? And, my first concern would be, as a user, doesn't it cause latency?
I love that question. That was a very obvious objection that we had to deal with from the early stages of design even. So we decided on the proxy approach because it gives us the most certainty that the data we're seeing is the one that the user is actually getting. As soon as a subsequent request has to happen from different infrastructure, we do not know whether that is really what the user got. Of course, you can use hashes and all of that stuff, but as soon as it doesn't match, it's harder to find the match. So the proxy approach was the more laborsome, hard thing to build, but the right thing to build. And the way that we countered the performance implications, because you are right, inherently, if you add a thing to the flow of a request, it's likely going to add a delay. Well, we counter that by doing some clever engineering. So when scripts are allowing to be cached, their cache control header defines it's allowed to be cached, and of course we cache them. And those scripts are being cached directly in memory on some of our edge locations. CDNs have to support large file sizes, and as a result, they have a more complex data storage architecture. And as a result, it can be a little bit slower. We don't have that because scripts are usually not that large. And then on top of that, our CDN that we provide for third-party scripts only do third-party scripts. That means we don't have to have 50 different mechanisms living in front of them doing all types of other things. And as a result, and a real-world example that I like to refer to is when you use a certain script, I'm not going to call out which one, from my flat in London, it would take 78 milliseconds to fetch that from its actual source. If you fetch it through Seaside, it only takes 48 milliseconds. The great thing here is there's a few things that also matter. The fact is that a lot of these third-party scripts are being fetched asynchronously. So the latency wouldn't even matter. Nobody would see it, nobody would notice it. And then the other aspect here is that as a proxy, if all these third-party scripts come through us, we can actually handle on a networking level these requests more efficiently, making these proxies even able to basically offset their entire latency just by doing that. So taking these requests and basically bundling them. And all those things combined lead to static scripts being served 30 to 40% faster, fully dynamic scripts being served about 10, 20 milliseconds slower. But if you have 50 scripts on your website and we can make 30 of them faster, those 20 other ones are not going to matter. They're going to be offset, and especially if those are asynchronously fetched. So the latency element we were able to basically counter as efficiently as we probably can today with the technology that's available. And technology like HTTP3 is actually making it more efficient to do these things as well. So that's another thing. All of these third-party scripts come from different servers. They don't necessarily support things like HTTP3, HTTP2, etc. We can actually do that for them through that proxy that we have. And that also makes for better performance. So yeah, that in more depth basically explains that performance aspect. And I know it's a highly sensitive part, and so that's why we talk about it, but it's not really the core reason why we do what we do.
Did I understand correctly that there's two ways? One is the proxy and the other one is perhaps, I can use your review capabilities maybe multiple times a day just to keep checking my scripts. Is that fair, or is there only one path?
So we are really only available as a proxy. And that is because that's the best way to deal with this issue. To give you that example of the polyfill attack, if you were to crawl that script from a certain endpoint, you would have not been able to spot the attack because the attack only injected the malicious script if the user agent was a certain mobile device browser in a certain geography. So the only real way that we're able to give you any level of certainty is by actually being part of the flow of the request, hence that proxy service. And I find it important that we don't give people a false sense of security. The proxying is the best thing to do. The every now and then screening approach is a bit of a hack and doesn't necessarily give you any level of certainty. And as a security company, people come to us to get the highest level of certainty that we can provide. So the crawler-based approach, we are not that enthusiastically positioning at all. But of course, we do some of that just to train our own detection capabilities and come ahead of new attacks that we haven't seen on our own customers' websites yet. We don't tend to productize that. I don't think that's whatever you want to do because, as I said, it can easily create a false sense of security, and that doesn't tend to help any situation.
So how do you secure your scripts?
That's a good question. Well, we have third-party scripts on our own website, and of course, we dogfood our own product. So we see a lot of these things behave differently over time, not necessarily maliciously. And so that's currently one of the ways that we tend to improve our detection capabilities is we have a whole bunch of websites with a whole lot of scripts on them. We tend to look for scripts on the web, on other websites. We then have a look at how they work. But for our own website, we are using our own product, funny enough, in the free tier currently, because that's what works best. We've got the stability, and that business and enterprise version we're still working on. So I'd say over time, we'll probably put ourselves as an enterprise customer, but currently we are just still a free tier customer using our own product.
I guess my question wasn't necessarily limited to third-party scripts, but in general, how do I trust that your script is actually going to do what it's supposed to do?
Of course. Well, so our script, of course, as we are a security company, we make sure that we take all the steps that we can take. So our infrastructure is secured, audited. We're going through SOC 2 audit right now. Make sure that none of the code that gets written can actually make it into that main branch without a secondary review. Our infrastructure is fully protected using commonly used things on AWS. Our proxy is secure. So we've basically gone through the furthest extent possible to make sure that our own script and our own proxy is safe. And we've even got fallback mechanisms built into that, tamper-proofing, tamper detections, etc. So we've gone quite far, even to the level where the domain name that we use, well, that is still seaside.dev, is a domain name that we've done everything we could to make sure will remain ours for as long as it possibly can. Funny enough, there are companies out there that allow you to basically have actual human verification. You have to walk into an office and show your passport to make a name server change. We haven't quite reached that level, but at some point we will. So we've gone through the furthest extent possible to secure our own script, our own proxy. And that, I think, is something that, we as a security company can give you a better sense of security than other third-party scripts that aren't security products. Of course, our own dependency management, we use a whole range of products for. I mentioned Socket in this call, of course. I love their product. I use their product. There are other tools out there that we also use. I think as most security companies and in general companies do, we don't tend to talk too much about all the security products we have internally, because that would allow people to try and bypass some of them. But yeah, we're layered, and of the amount of money we have raised, a good amount of that money is being spent on making sure that we are safe and everybody is properly trained, that we know what to look for, and in case something bad happens, that we are the first ones to know and that our customers are not impacted using multiple environments, etc.
Thank you, Simon. Any topic you think we did not cover that you'd like to talk about?
I feel like we've done a rather comprehensive review of all of the issues with it, the potential risks there are. I think that was pretty comprehensive. Yeah, I think that was it really from my side.
Simon, how can people contact you?
So the best way for people to get in contact with me is by going to our website, seaside.dev, and go to the contact section there, because that will just end up in my mailbox. You can try and send me a message over LinkedIn or Twitter, but I'm pretty bad at responding at those sometimes. So probably the best bet to just go to our contact page.
Thank you so much. I hope our listeners learn from this and start to recognize that this is a real problem that they should keep an eye out.
Thank you very much.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.